Hello people, welcome back to my channel. So today in this video, let's see the another classifier evaluation method, that is we have the bootstrap approach. So far we have learned different types of classifier evaluation methods, that is we had the holdout approach, then we saw the random subsampling, then we have the cross validation, nested cross validation. So what remains constant or common throughout all these previous approaches is that once the training record is used, it cannot be reused again, means there was no replacement at all. But in Bootstrap, the training records are sampled with replacement, means once it is used, it is put back to the original data pool and it has an equally likely probability of being redrawn. So let's consider this example. So this is our original data set represented by Z, and so it has three observations, that is we have n is equal to 3. Let the size be represented by capital N. Small n is the observations. Now you have 10, 11 and 12 instances. You have x and y as the attributes, then you have some class labels. So what you can see, this are the mimicked copy of the original data set. So what I said is, that is with replacement, means the instance 10 can appear twice or any number of times. So there is an estimate given. So if you have the original data set is of size n, then a bootstrap sample will contain 63.2% of the original bootstrap sample of size n. So here you can have two instances or any number of instances, that is 10 is repeated twice here. Similarly here 12 is repeated twice. So you can have any number of bootstrap samples, and so B represents a number of bootstrap samples. So how much you can generate? So B you can just keep it to 100 or even 1000, or can be any number. So this is the just suggested bootstrap samples required for your data set. Now what you have is, with this bootstrap sample you just estimate an alpha value. So this is an alpha estimate that is just recorded for the standard error. So mainly bootstrap is used for standardization error. So it's given by this formula, that is under root 1 upon b minus 1 summation I, which runs from 1 to b, that is number of bootstrap samples, and then you have the alpha estimate for each of the generated bootstrap samples, and its mean alpha estimate is done and it's subtracted, and the square is given for this standardization error. Now this again is used for confidence interval. So where you get some percentiles, that is 90th percentile, 50th percentile, 45th percentile. So there also bootstrap sample is used. Now what is the probability that each record is taken again? So this probability is given by, that is 1 minus 1 upon n, the whole raised to n. Now if your n is sufficiently very large, then what this becomes is 1 minus e raised to minus 1, which is 0.632. Now the records which are not part of this bootstrap sample becomes the test set. Test set is that record not part of bootstrap sample. And so as you can see, there is a sampling technique which is applied at each of the level, and for that you calculate an alpha estimate. Now with this training data you just create a model and its performance is evaluated on the test set. Now with this you have the accuracy. So the accuracy is given by this formula, that is accuracy of bootstrap 1 upon b, that is number of bootstrap samples produced, and summation over 1 to b. 0.632 is the probability that how much it is chosen, multiplied by Zi, that is the instances that you create, plus 0.368 is another estimate for the accuracy of the samples which is created at each bootstrap level. So well, that was all regarding the bootstrap approach in machine learning. So hope you guys enjoyed this video. If you found it educative watching this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.